So now the first experimental पे बाद में आते हैं, पहले तो quick recap. A rate is you measure the change that's happening with respect to time. This was the first thing that we studied, which was the half-life method. Okay, what you do is you plot the reactant concentration and you see how it varies with respect to time. So if the reactant concentration is decreasing and it's decreasing with constant speed, reactant concentration always decreases. But if it decreases at constant speed, that is zero order. That means the reactant concentration decreases and the rate, nothing happens to it. The speed or the gradient remains constant. Then there's order one. A reactant concentration decreases and the reaction slows down. It takes longer and longer time. You get a curve. And this is a constant. This one has a constant half-life. So the half-life over here is constant. And the third thing was that the reactant concentration decreases and the time taken, it just keeps on increasing. So that is order two. The reaction slows down by a much bigger amount. Then we figure out there's order 0, 1, and 2, and then we figure out it has a lot to do with mechanisms. That a reaction, anything that's involved in the fast step, the rate of the reaction is not going to be dependent on that. Reactions, they always have multiple steps. So so if one of them is a slow step, that is the rate determining step. The rate of the reaction depends on any reactant that's involved in the slow step, not on the fast step, because speeding up the fast step will have no negligible overall effect on the speed of the reaction. If this takes 100 seconds, this takes 1 second. I mean, it's pointless to increase the 1 second step. I mean, you increase the concentration of OH ion, nothing pretty much happens to the overall speed of the reaction. 101 se wo zyada kya ho jayega? 100 seconds pe aa jayega. So pretty much negligible effect happens. So, and we also discussed order two. I told you that you've got to replace and trace intermediates. So if this is a slow step, rate depends on NO concentration and BR concentration, but BR is an intermediate that was made in the previous step. So when I say rate depends on BR concentration, it indirectly depends on the concentration of NO and BR2. Okay, if their concentration would be high, then BR concentration would be high. So rate indirectly depends on NO and BR2. So that is why NO appears twice in the expression. And that is order two. Because by changing the concentration of NO, not only will the slow step speed up because NO concentration changes, but NO affects BR's concentration. So BR's concentration, so the rate of the reaction would be affected 2 times. So it would be squared, like it's going to double and then it's going to double again. It's going to double because NO concentration doubles. And because of NO concentration, the BR concentration also doubles. So the rate of the reaction speeds up twice. So that is a quadratic relationship. So we did all of that. And in the last class, we talked about the third method, which was the experimental method. If you want to figure out whether the rate is 0 order, 1 order, or 2 order, you just you do different experiments and you just alter one of the experiments and figure out how the rate is affected. So for example, if you compare experiments 1 with 3, NO's concentration is halved. It goes from 0.1 to 0.05. The rate over here becomes 1/4. So that is from experiment 1 to experiment 4. So that is order 2. If you compare experiments 2 with 3, which is done over here, then O2's concentration is halved and the rate of the reaction is also halved. That's directly proportional. So that means it's order 1. So you can figure out the order by just looking at this. You can do multiple experiments and compare those experiments. Now, things are not going to be this easy. Like it's, I mean, you get a lot of questions on table. So let's copy here. Let's look at the worksheet. Okay, 2020, yes one. So if you have a look at this worksheet, it's going to be that this table over here. Let's try and figure out how the rate. So he's saying, so let's just paste this over here and let's try and figure out how the rate of the reaction is going to vary. So I think that's, so we're going to try and figure out how the rate of the reaction is going to vary. So the reaction over here has two reactants. One of them is this. The other one is this one. So that means rate depends on, so we can say that rate, the rate of the reaction, it depends on both reactants. It depends on NH3's concentration. We just don't know how it depends on that. So the order is not known, and it depends on ClO-1 concentration. And we're not sure how it's going to depend on that. So this is what we are looking for. We're trying to figure that out. So can anyone tell me which experiment should I compare to figure out the order?
Sir, second and third.
Okay, so we can, so remember you have to keep one of the reactants constant. The second and third, because say second and third. So you want to keep one of the reactant constant. So I'll compare experiments, experiment 2 and 3. Okay, that's going to be my reason. I'm comparing experiment 2 with 3. अच्छा, जब इनको compare करोगे ना तो पता लगता है कि भी ClO-1 concentration is unaffected. You're not changing it. What you're doing is you're doubling NH3's concentration. So that's clear. NH3's concentration doubles. Concentration doubles, becomes 2 times. What happens to the rate of the reaction? It becomes 4 times. So this one is doubling. You can remember it's the factor, the change, the factor important है. This divide by, मैंने पहले बताया था कि नीचे वाले number को ऊपर वाले से divide कर लो, you'll get the factor. So NH3 concentration doubles, and what happens to the rate quadruples. So that's order. What order is that? With respect to NH3. कौन सा order?
Order 2.
Okay, so that is order. So that is order 2. Okay, so that's fine. We did that. But remember, we just figured out NH3's order, right? We did the first one, this part. What about ClO-1? So I'm going to rub this off again. Now, how would you, which experiments would you compare for ClO-1?
Experiment 1 and 2.
A problem is if you compare experiments 1 with 2, so the rate is changing, but you're not sure is it changing because of this or is it changing because of this. दोनों change नहीं होने चाहिए, वरना आपको पता नहीं लगेगा किसी वजह से वो rate change हो रहा है. Do you get my point?
Yes.
Like if I want to figure out the order of ClO-1, all the other variables must be constant, which is basically NH3. लेकिन अब यहाँ पे मसला ये, I mean, if this should, I would change this, I would keep the other one constant, and then I would figure out how is the rate getting affected because I'm changing ClO-1. But the problem over here is कि यहाँ पे कोई ऐसा experiment ही नहीं है. Like if you pick any experiment, 1 with 3 or 1 with 2 or any experiment, you change ClO-1 concentration, NH3's concentration is also changing. So you can't be sure कि ये जो rate में change आ रहा है ना किसकी वजह से आ रहा है, इसकी वजह से आ रहा है, इसकी वजह से आ रहा है, ठीक है? So is that clear? So we have a problem over here. Is this clear to everyone? Okay, what's the problem?
Yes, sir.
ठीक है. अच्छा, तो अब how do you solve that problem? What you do is कि एक का तो order पता लग गया ना कि you figure out one of the orders. You know that NH3 is what order? NH3 is order 2. ठीक है, so you know one of them. So दूसरे वाले का नहीं पता कि what is that? ठीक है, you don't know what the power is or how it's going to affect rate. So you can compare any experiments. Let's compare experiments 1 and 2. Now I'm not comparing them. What I'm doing is I'm going to solve this simultaneously. I know the rate equation. What is the rate equation? The rate equation is that rate depends on your two reactants. So the rate of the reaction depends on ClO minus 1, and I have no idea how it depends on that. So it's X. But I know what NH3, it depends on NH3, and I know exactly how it depends on NH3. So NH3 की power क्या होगी? It's squared, right? Proportionality भी हटा देते हैं. Let's just put a K over there. So I have a rate equation, but there's an X that I need to find out. So what I'm going to do is, कि मैं बारी-बारी experiments 1 and 2, I'm going to substitute both values here. So if I substitute both values, let's say experiment 1. Experiment 1, the rate is 0.256. So it's 0.256 is equal to K, and ClO minus 1 concentration is 0.2. ठीक है, वो कहाँ पे? यहाँ पे. And NH3 concentration, and it's power X. And NH3 concentration is 0.1. So that is, 1 second. So now that is 0.1. और इसकी power क्या है? इसकी power हमें पता है, it's 2, right? So this is by experiment 1 data. ये clear है कि I have the rate equation, but there's an X, there's an unknown over there. There are two unknowns actually. K का भी नहीं पता क्या है. So is this clear? I've just substituted values here.
से K क्यों लगाया आप लोगों ने?
नहीं, वो proportionality था ना. Rate is proportional to ये दो reactants है ना. तो वो proportionality खत्म करो तो constant आ जाता है. That's the rate constant. ठीक है. वो हर जगह हमने K डाला था. वो तो हम K को भी कोई खास importance नहीं दे रहे. लेकिन once you figure out the order, it's rate is proportional to NO's concentration squared and O2's concentration power 1. इसका मतलब है directly proportional इसके ऊपर है. K would come in when you get rid of the proportionality. ठीक है. अच्छा, अब यहाँ तक तो हो गया कि अब the problem is was carried out. Now the problem is this is experiment 1 value. So how do you solve a simultaneous equation? You need two equations for it to be a simultaneous equation. So I'm going to do experiment. I'm going to input experiment 2 values into this. So experiment 2 value is 2.05. I think 2.05. Yes. वो हमारा rate हो गया is equal to K. ClO minus 1 concentration is 0.4, and that's power X. And the other one is 0.2, and that is squared. So this is my my experiment number 2 values that I've substituted. तो अब
तो ये आपने 2 से मल्टीप्लाई किया?
नहीं, मैंने experiment 2 की values put कर दिया उसमें. Rate equation, we have the rate equation, right?
अच्छा ये हाँ ठीक, ओके.
तो मैंने experiment 1 का data उसमें put किया, वो experiment 1 की values बीच में डाल दी, and I've inputted the experiment 2 values as well. ठीक है, is this clear?
Yes.
अच्छा, अब इन दोनों को what you have to do is you've got to solve them simultaneously. ठीक है, and you have to find the value of, you've got to find the value of X. What you can do is you can, I mean, the constant remains the same because it's the same reaction. It's an equilibrium constant that remains the same. So what you can do is you can either use this K. I mean, what would this K be equal to? I mean, this K is equal to 2.05. So it's equal to 2.05 divided by what? 0.4x power X. Sorry, power X. And the other divided by 0.2 squared, right? So use this K and substitute this K into the first equation. So I'm going to substitute this K into the first equation. So it's going to be 0.256 is equal to K. So I'm going to plug in the K value. The K value is 2.05. And it's going to be divided by what? Divided by 0.4x. Just make sure I'm not making any mistakes here. Mathematical mistakes. 0.2 squared. Right. So this is 8 and वो बाकी values, it's going to be 0.2x. And it's 0.1 squared, right? And now what's left is I have to figure out what x is. यहाँ तक clear? Is this clear? This thing?
Yes, sir.
Yes, sir.
Okay, so this is, I'm just substituting 1k into the other equation. Now I need to solve this. So I'm going to take all these numbers over here. So it's going to be 2.05, 0.2 square को उठा के इधर ले आते हैं. So that would be, इसको थोड़ा सा नीचे कर लें. अच्छा, so 0.2 squared, must be silly mistake. No, that's, just be careful about that. Otherwise it's simple. 0.1 squared, get it to the other side as well. So I'm left with, if I rub all of this, what am I left with over here? I'm left with this thing. Achha, can somebody do the math and solve this? What do you get for this? कोई भी इसको solve करे, what do you get? Zahib, Ibrar, anyone?
0.499.
So approximately 0.5, right? So you're getting 0.5.
Five.
That's it. Achha, what is 0.2? Isko bhi simplify kar lete. It's going to be, I mean, this is basically equal to half x. Like what I can do is, what I can do is I mean, this is what it is, right? 0.2x over 0.4x is basically 0.2 over 0.4 whole x, okay? And that is basically equal to half x. So it's equal to 0.5 x. Now, if you want to figure out what x is, it's fairly obvious. X would be equal to 1. Like that's the only way. 0.5 to the power x is equal to 0.5. The only way that's possible is that if x is 1, if 0.5 has a power of 1. So x comes out to be equal to 1. So is this clear? Is the working clear?
Yes, sir.
Is this clear to everyone else? Zoha, Minahil, Ibrar, Hafsa, Alicia.
Yes, sir.
Achha, so remember, you've got to do this when you're given a table. Iska figure out karna aasan tha because NH3 concentration changes and you're keeping the other one. I mean, if you compare experiments 2 and 3, this one is kept constant. So you know that the rate is getting affected because you're changing this, right? So you can figure out the relationship, whether it's, I mean, this is doubling and it becomes 4 times. That kind of indicates that it's order 2 with respect to this. So that was easy. So the reactant that you're trying to investigate, you have to change that. That variable should change. All the other ones should be constant. But that was not the case for CLO minus 1. You wanted to change CLO minus 1, but the other one was also changing. So that kind of messed up things. So you had to solve this simultaneously. So we're going to do some more questions. I mean, that's about it in this one. So we'll just practice more questions. Give your reasoning. The reasoning is exactly the same. You have to show your working. Now, the remaining part is that you'll be asked to figure out the rate equation, which we actually did in this case. What did we get? X is 1. So my rate equation over here would be, so my rate equation over here would be, I already know that it's NH3 squared. So this one was squared and this one was power 1. So rate is going to be K. NH3 concentration is going to be squared. And what CLO minus 1 concentration would be power 1. So that's a rate equation. The very last thing that they were going to ask you about is calculate the rate constant and using experiment 1 data. So all you have to do is you just have to input the values for experiment number 1, which is that the rate is given. That's experiment number 1 is 0.256. K is not known. NH3 concentration for experiment 1 is 0.2. And that's power 1. And the other one is ClO minus 1, that's 0.1. And that's, sorry, NH3 squared. So I think this is NH3, 0.1 squared. And this is power 1. So 0.1 squared is, I'm not sure. It's, I think, 0.01. So can you figure out what the value of K is?
I'm getting 128.
128, okay, that's fine. So it's 128. The other thing they're going to ask you about is the units for K. So you figure out the value of K. What are the units for K? The units are quoted over here. So the rate unit is mole per dm cube per second. So I'm going to just do that. So rate is mole per dm cube per second. K, I'm not sure. NH3 concentration is mole per dm cube. And that's going to be squared. And ClO minus 1 concentration is mole per dm cube. And that's power 1. So I'm just going to take mole per dm cube as X. So it's X S minus 1 is equal to K. And it's going to be divided by X squared into X. So K comes out to be equal to X to the power minus 2. S minus 1, and we can substitute mole per dm cube. So it's going to be mole per dm cube to the power minus 2. So mole minus 2 dm 6 and S minus 1. Is that clear?
इससे तो ऊपर हमने क्या कैलकुलेट किया? K की वैल्यू कैलकुलेट नहीं की?
नहीं, अब K का यूनिट भी कैलकुलेट करना ना.
अच्छा.
मतलब यूनिट तो वो है ना कि यूनिट तो
जी.
मोल per dm cube per second वो उससे दिया हुआ था. रेट का यूनिट क्या है? मोल per dm cube per second. और फिर it was mole per dm cube squared into mole per dm cube, right?
Oh yes.
So on the axis, sketch a graph to show how the value of K changes as temperatures increase. Remember, we wrote this down very early. K just keeps on increasing when temperature increases. Very early on. If you look at this equation, the concentration is kept constant, and if you increase temperature, the reaction speeds up. That means K increases. K is only a constant, and I have definitely written it somewhere. Okay, the value of K on this one. The first time we introduce this constant, it's a rate constant, it increases with temperature. क्योंकि अगर concentration same रखी हुई है, so why is the rate increasing? Because the K value is increasing. And that's the only thing that changes. Otherwise, it's a constant. So ये graph वाले questions कर लेते हैं कि but we can now do the whole question actually. So let's try and do the. Is this the first question? Let's start with this one. अच्छा, order निकालो. क्या आ रहा है order? Which two experiments would you compare for NO? Remember, if your NO should change, the other one should remain constant. So which experiment would you compare for NO? क्या होगा? We want to figure out the order with respect to NO. Anyone कौन से experiments compare करोगे?
1 and 2.
No, not 1 and 2 because 1 and 3 is order, right? That's fine. You want you want NO to change and all the others should remain constant. So in 1 and 3, NO changes, O2 remains constant. So the rate is being affected by NO only. Zaib, is this clear?
Yes, sir.
So what you're going to do is, this is your explanation. If you compare experiments 1 and 3, What happens to NO? NO concentration is halved. And what happens? ये मेरे ख्याल से हमने किया भी था. It becomes 1/4, right? So rate becomes 1/4. So rate becomes 1/4. Hence, order is 2. अच्छा, what about the other one? O2 concentration. ये जल्दी से बता दो कि which two experiments would you compare for O2?
Sir, second
सर
and third.
ये
ठीक है.
ये
हाँ.
पहले वाले में 1 और 2 क्यों और फिर NO is halved, rate is 1/4
1 and 3.
just order.
NO के लिए करना है तो NO should change. O2 should remain constant. तो 1 और 3 में NO कितना हो गया?
अच्छा.
Half हो गया. O2 तो constant रहा ना. You didn't do anything to O2. So that means the
Yes.
rate is basically changing because you're changing NO.
ठीक, alright.
और अगले में it's going to be comparing experiments 2 and 3. तो उसमें क्या हो रहा है कि O2 is the one that's changing. O2 is halved. And rate is also halved. मतलब वो भी आधा हो गया. So it's order 1, directly proportional. Achha, next one, which is he's asking you to find to state the rate equation. So it's order 2 with respect to NO. So K times NO squared. And O2 is going to have a power of 1. And he's asking include units for the rate constant and calculate the rate constant. The rate constant किसी एक की भी values इसमें input कर दो. So, and you have to figure out the unit as well. So I'm going to use experiment number 3. The rate is 0.875 is equal to K times 0.05. And that's squared into 0.05. Power 1. So basically 0.05 cube आ गया. तो K की value क्या आ रही है? What do we get for that? और K की unit भी निकालना है. So it's mole per dm cube per second. So rate divided by NO squared, mole per dm cube squared into mole per dm cube. अच्छा, इसका क्या है हमारे पास? What do you get for this?
I'm getting 7,000.
Okay, so the rate constant is 7,000 and the units for K are mole minus 2 dm6 and it's S minus 1, right? So we are getting this. So let's try the next one. Now in this question, they've already given you the orders. Okay, state the order with respect to the following. So there is, I said sometimes also remember they make it a point. Sometimes the catalyst concentration also matters. The rate of the reaction depends on the catalyst constant. I mean, like over here, it is dependent on the catalyst. So it's not just the reactants, but any catalyst involved as well. So here you can see that it's order 1 with respect to this one, right? Because the rate equation is already given to you. With H plus 1, it's again order 1. I said rate equation में I2 नहीं लिखा हुआ. What does that mean? What is the order of I2 if it's not written in the equation?
0.
ठीक है, so that's order 0. So that means rate is not dependent on I2. So we have that, and the rate equation is already given to you. So calculate the rate constant K for this reaction and state the unit. So he gave us everything. You just have to plug these values in. The rate is given, so it's 5.4 times what 10 to the power minus 3 is equal to K times now the I2 concentration is irrelevant. 1.5 times 10 to the power minus 2. And the other one is H plus 1 concentration. That's also given over here. That's 7.75 times 10 to the power minus 1. तो K बता दो क्या आ रहा है और units भी. What do we get for this?
$0.46.
ठीक है, so we're getting 0.46 and what are the units? Rate जो दिया हुआ है mole per dm cube per second x s minus 1 is equal to K mole per dm cube into mole per dm cube, so it's x into x. So that would be x squared. X would get cancelled out, so it's x minus 1, s minus 1. So it's mole minus 1, dm3 and s minus 1. That's the unit for rate constant. Okay, every time remember, if the equation is different, the rate units would also be different. So is this clear?
Sir, what would be the overall order for the section?
It's going to be order 2. क्योंकि वो सारी कहाँ पे लिखा हुआ है उसने, did he ask for the question? Like he gave us the individual orders, the overall order would be 2. क्योंकि one is this and one is this. So if you want to figure out the overall order, so what you have to do is, यहाँ पे मैं point भी लिख लूँ, although you didn't ask for it. Just remember that the overall order जो होता है ना, that is the sum of all the orders. ठीक है, that's the overall order of the reaction. Clear? अच्छा, if I complete the table placing one tick, what is the effect of decreasing temperature on the rate constant? तो उसकी वैल्यू छोटी हो जाएगी. अगर वो बढ़ाने से increase होता है, if you decrease it, it's going to become smaller. And the rate of the reaction would also decrease. Remember, whenever you decrease temperature, the rate of the reaction would also decrease. So what's going on over here? Find from the results, a graph is produced which shows how the concentration of I2 changes during the reaction. Describe how this graph could be used to determine the initial rate. अच्छा, experimental के अंदर ना, we missed this part, which is kind of important. And it should have been discussed right at the beginning, early on. यहाँ पे. So just a quick, there's one small point that we missed, and that is, you look at a reaction and if you try to figure out the speed of the reaction, it's basically how quickly does change happen, change with respect to time. So the rate of the reaction is not a single value. Like if there's a reaction going on, अगर आपने Coke, if you added a fizzy drink in your glass, the reaction happens very quickly at the start. So it's fast and then it slows down. So the rate of the reaction is constantly changing with respect to time. Like it's not a constant value, it changes. Start में तेज होता है, बाद में slow होता है. So that's pretty obvious. Now the problem is when you measure when you do these calculations and when you talk about the rate of the reaction or you measure the rate of the reaction, time is important. कि भाई कब आप measure कर रहे हो? Like if you measure the rate of the reaction after 10 minutes, maybe the reaction has stopped and you'll get no value. It's going to be 0. The rate of the reaction is 0. But if you measure the rate of the reaction somewhere in the middle, the reaction would be happening. If you measure the rate of the reaction right at the beginning, the reaction might be happening very fast. So which rate value are we talking about? So to remove this confusion, it's always the initial rate, which is you make the tangent right at the beginning and you always compare initial rate. क्योंकि आपको पता है every reaction after 5 minutes would just slow down and come to 0. So why measure the rate after 5 minutes or 2 minutes? You always measure initial rate. Is this clear? You clear?
So like in conclusion, we will always draw a tangent from the start.
हाँ मतलब for example you saw these all these values, right? And there's a rate value that's mentioned over here, that this is the rate of the reaction. And I just told you that the rate of the reaction, as the reaction is going on, it constantly changes. So why do we have a fixed value? I mean, 5 minute बाद वो 0 पे चला जाएगा ना, हो सकता है reaction खत्म हो जाए. And right at the beginning, it's very fast. So just to get a constant rate value, what is done is that you always measure the initial tangent. कि start में क्या था, right at the beginning. You always measure and compare the initial rate. You don't measure the rate after 5 minutes or after 10 minutes. Hamesha start wala. And it doesn't matter whether the change is going up or down. It's the gradient or the slope that we're interested in. This yahan pe tangent is going down and the tangent is going up. So, I mean, the direction of the tangent is not important. How steep is it? ऊपर जा रहा है तो कितना steep है, नीचे आ रहा है, so the changes can be decreasing changes, they can be increasing changes. तो वो जो direction of change है ना, that's not important. Is that clear? This thing?
Yes, sir.
ठीक है. So remember, whenever you're going to compare two reactions, you're always going to compare the initial rate. 50 सेकंड बाद नहीं measure करना, 1 मिनट बाद measure नहीं करना. It's always the initial rate. Okay, बिल्कुल start पे what was the speed of the reaction. So is this point clear? ये clear है सारों को?
Yes, sir.
बस ठीक है. चलें, we'll do more past paper questions now in the next class. ठीक है? Okay, everyone.
Thank you, sir. Allah Hafiz.
Allah Hafiz. Take care.